In this final tutorial of the Godot series from SmartFoxServer, in association with PivecLabs, we will look at the development of a full multiplayer first- and third-person combat game with Godot and SmartFoxServer. Using the link below, download the shooter multiplayer example project from the Godot Asset Store and open it in your editor. The example game project utilizes the ability to mix TCP and UDP-based messaging and makes full use of the SmartFoxServer lag monitor. More can be learnt about the differences of TCP and UDP in the online documentation. In our example code, all critical game information between the server and client are sent using TCP for reliable delivery. This could be shooting, animation sync, damage messages, etc. On the other hand, sending updates of the player's transform, which is continuously sent by and to all clients, is executed using UDP, which is significantly faster and more efficient, but cannot be relied upon to reach its destination. This example project will run without any changes. However, it is easily configured for whatever form your game may take. Most changes can be done in the Godot Inspector panel from each scene, such as different characters, colors, and UI elements. This is relatively straightforward, but does take a basic knowledge of the Godot Inspector, which is outside the scope of this video. However, we will cover the code structure and how it relates to real-time game development for multiplayer projects. The main components in the client project are found in the scripts folder. They are as follows: the game manager, the character transform, and the player script. The Java extension for this project is somewhat more extensive than the tic-tac-toe example. It includes handlers to communicate with the client and simulation code to handle the player transforms and positions within the world simulation. This means that the world simulation runs on the server side, and all clients have a representative simulation running on their system. Once the player has logged in and either started or joined a game, the game manager calls the method sendSpawnRequest. This method selects a random character prefab from however many have been added to the game manager in the Godot Inspector panel. A random color is also selected, and this will be applied to the first material on the model, which in our case is the shirt. The prefab number and selected color are placed in a SmartFox object and sent to the server extension as a SpawnMe request. On the server, in the transform script, there are 8 spawn points. These are hard-coded to provide better security from hacking or cheating attempts. To avoid the spawning of characters on top of each other, if the random spawn point results in the same position, the character is instantiated a random value of -2 to +2 on the X and Z axis, and this position is updated on the server by the client. This may need to be amended with larger size characters. The position of the player is stored in the world simulation, and a spawn player event is transmitted to all users. The event dispatched from the server will contain the user ID, the selected prefab, the color, and the score in case it is respawning. On the client, this event will call the handleInstantiatePlayer method. This method will spawn the corresponding character. If it is the player, it is flagged as local player, so the player camera and input controller can be attached, or if it is not the player, it is instantiated as a remote player. Each of the actions are handled in a similar way as in other demo projects. For example, when the player shoots, a send shot request containing the target is forwarded to the extension. The extension processes the request and dispatches an event. The event received by the client calls the handleShotFired method, which processes the animation and audio. The target is raycast by the client, and not the extension, but the other calculations such as ammunition count, wounding, kill, etc. are done by the extension. A targeting system could be built to enhance the server extension and not use raycasting on the client, but it would need to take into account all game objects in the scene, including buildings and props. This is currently outside the scope of this example project, but would add to the authoritativeness of this game code. The character transform script is used to build a SmartFox object containing the character position, rotation, and aim rotation vectors. The X, Y, and Z vectors from each vector 3 is extracted and a timestamp is added. This is actioned every frame when the player's physics process loop calls sendTransform in the game manager. However, it does not send a transform to the server extension every frame, as it checks the time the last update was sent, set in the sending period. This is currently set to 0.03, which results in 30 updates per second, or every second frame on a game running at 60 frames per second. While this may seem a lot to some, these updates are sent using UDP. As shown here, UDP is set by coding true on the extension send request in the send transform method. The character transform script also acts in the reverse, building vector 3s from the SmartFox object sent by the server extension. These are then used for character positioning in the world simulation, as well as the interpolation code. If the network sync mode complex is selected in the game manager, the sync character method will be called for remote characters and will use interpolation for the position and rotation of characters. As described in the code comments, we buffer 30 copies of the transform received, the position and rotation, and using the SmartFox lag monitor, we calculate how far back we go within the buffer to compensate for any network lag. Using a server extension in this way ensures that the characters in the client game are in the same position as in the world simulation on the server. Other variables that can be altered but require a change to the Java extension are settings such as the maximum health, the maximum ammunition reserve, and the ammunition loaded. These would need to be changed for different weapons, or the UI depending on your game design and format. The server script also contains the world bounds. If you wish to create an arena shooter or an open-world game, you may need to alter these settings. They are found in the world script within the Java extension. Check out our online documentation at smartfoxserver.com. Here you will find resources and other tutorials, not only for Godot, but other supported client platforms. You will also find a detailed written tutorial for this video. Using the skills you have learned from these tutorials, you can modify the shooter example to include a character selection screen or change the environment completely and develop a chat group hangout. SmartFoxServer has also been used for real-time battle games, as well as multiplayer vehicle racing. Check out other tutorials from SmartFoxServer and PivecLabs.